the RxJS ReactiveX advent of code. So we've been through quite a bit so far. This is the 18th day of the Advent calendar. So we've had a lot of things that we've already covered, and obviously there's a lot more that we want to cover before this whole series is through. So let's catch you up as to where we are today. So we've covered a good amount of data about the reactive extensions. In that we started with creating the observable, and like I said, if you missed any of these, there are videos online of each or most of the material that we've covered here, if not all of it. And if there isn't, please do file an issue and make sure that we do cover it before this whole session is through. So the second thing we covered was the aspect of schedulers. So we covered the first part, which was the pieces of the observable, which is the observable itself, which is the emitter of data, the observer, which is the sink, and then finally the subscription, which is the composition piece that allows us to take one piece and compose it with another and compose it with another and have a deterministic teardown for all of that. From there, we covered creating observables very easily through a number of generation functions such as generate, of, and those sorts of ones, as well as eventually through timer and interval, which for gaming purposes or for long polling purposes that you would certainly use there. Then, of course, we talked about taking your existing data structures, such as promises and iterables, arrays, and generators, and turning those into observables as well. And there are certainly some advantages of doing so in terms of just the performance of Rx is pretty good for a lot of these data structures, especially over using some of the built-in things like array. Not that I would suggest that abandoning the array methods and array extras, but I'm just saying is the fact that there are some performance advantages to be had there. Then we talked about the basic composition model, which is that we moved away from the dot notation operations and more talked about how we were going to allow composition going forward from this idea of the lettable operator, which eventually became pipe. And with that, that allowed us to only include the bits and pieces of Rx that you absolutely want or need, and not having the extra cruft there that you don't need. So that's kind of nice, especially when you're more sensitive about the bundle sizes and so forth, that you want to get the maximum amount of Rx, but you don't need the whole surface area of the library itself. So that's really handy to have for that piece. Then we went into the very basic operations of composition, in that we have map and filter, which once again I brought up with arrays earlier, the idea that we have a programming model very much based on arrays in terms of if you know one, then you certainly know the other, in terms of if you know what array prototype map does, then you probably understand what map does for observables. And the same really applies to filters as well. Then moving along, we went to scan, which helped us understand how to build up state over time, which is very, very useful, especially if you're trying to implement something like Redux. And that's exactly what we did on the 12th day of this, which was we took the knowledge that we already gained with our subjects, which is the ability to create our own event emitters, as it were. Each of them having their own style, as it were, whether it's retaining all of its data from the beginning of time, whether it's having an initial value, or just caching an asynchronous computation. There are different types of subjects, and you'll definitely want to take a look at that if you're not already familiar with subjects. And then we started getting into combining sequences because a sequence unto itself is not super interesting, but when you start to combine these things, that's when it gets a lot more interesting. So, for example, we can go through and combine sequences such as mouse movements and something else with combined latest. So the idea there is that we can combine the streams as long as both sides have emitted data of some sort together. So if you want these two particular things to emit, no matter if the left side or the right side has changed, then combined latest is your friend in terms of that particular scenario. Then we went to combining sequences of sequences. And that's where it got a little bit more interesting in that we have this notion, unlike promises where you can't have promises of promises, you can have, just as you can have arrays of arrays, you can have observables of observables. And the reason why that's interesting is for composition purposes of where we're taking an initial value, say an event of data, and stringing it along to make an HTTP request of some sort, whether it's the fetch API or something else, to go and make that call, get that data back, and then turn that into an observable sequence itself. So it's kind of nesting these calls throughout the entire pipeline. So we have a number of ways of doing that, and the first one, and what I call the smushing of sequences, using the great term that came up for flat map, because it became very much a point of contention where flat and others were already used, so therefore we need to use smush or some other word to describe how we're merging these two collections together. So that became a whole thing called Smushgate. So I thought, why not just have smush as become part of our lingo here when we're talking about combining sequences. So we had concat and merge, but here we have concat all and merge all. So we can take simple sequences of 1, 2, and then another of 3, 4, and another of 5 and 6, and concat them all together after they've been created into their own sequence. And obviously that keeps it all nice in order, because that's what concat likes to do, is to take things in order. Once they've ended, start the next one. Once it's ended, start the next one, and so forth, in a non-concurrent way. However, when dealing with concurrency, it's kind of our bread and butter, as it were, with Rx, is that we're dealing with values over time, and we're dealing with potentially infinite sequences. So really the last thing that you'd want to do is always wait for an end before you start doing something materially useful for the next transform. So we have merge all, which does our concurrent smushes. So we can say, okay, take these particular three of these particular sequences and smush them together, and whatever happens in terms of their values that come back. So that's kind of cool in the fact that we can then basically merge these all together, and its order is really non-deterministic in terms of which one fires first. In terms of just whichever one happens to be ready, that's the one that fires. But of course, with any merge operations, that we can set its max concurrency, whether it's 1 or 2 or 3 in this particular case, to cut that down so that we can chunk our concurrent work as we go along. So that was nice in terms of allowing us to smush these sequences into a single sequence that we can listen to and react to later on down the line. Now, going forward, though, is that really super useful with concat all and merge all? Well, not really, in terms of it's not super useful in that how often do you have these particular things versus how when do you project something from the inner inner observable or your first observable, and then create something as projected, which is another observable, into the next piece. And that's where this map operation comes in. So this map is the operation that's creating the observable, and then it's up to us via the next operator, the next piece of that, to determine the concurrency level in which we want things to happen. So for example, if we do concat map, we can easily take our data, and as it comes through, we can concatenate one onto the other based upon the data that comes in. So in this particular scenario that we have covered here, we have getting our data here from of 1, 2, and 3. And what we do is we pipe that through concat map. And so concat map will then let us peer inside of the first observable, which is the 1, 2, and 3. And then we can take that and create of, which in itself turns that single item into an observable as well. And what we're going to do from there is then we're going to delay that by a second. So we're going to take that and delay it by a second based upon where it is in the chain. So for example, the first one will delay by 1 second because it's 1 times 1,000. And then subsequently, the next call will come down and 2 times 1,000, so 2 seconds, and then the third one will come down and delay by 3 seconds, or 3 times 1,000. But of course, we want to give you some interesting diagnostic information as we're going along, such as where exactly are we in this particular operation, and how much was it delayed by. So what we can do from there is then do an additional map operation on top of the delay to give us some richer text that we can show to the user and say, hey, by the way, not only did we delay the value, but we also projected it to something else, something much more useful. And what you get from that is that when you subscribe, then you get item 1 delayed by 1 second, and item 2, and followed by item 3. But that's really cool, is the fact that we're using our composition in such a way, building up these pipelines, as it were, through our pipe operator. And hopefully it doesn't look too foreign versus what you would have done in the dot notation world previously. Whereas it would have been, of 1, 2, 3 concat map, and then inside of there you would say concat map dot delay dot map in there. But honestly, this reads just fine to me. I'm sure there will be many others that have their own opinions when it comes to readability and grokkability. But for me personally, this is a pretty good trade-off in terms of creating fairly readable sequences. And not only that, but if you're having something that you're dotting into 9, 10 times, chances are debugging that particular piece is going to be problematic, because in isolation, trying to model each behavior over time is not exactly easy. If you're talking about delays and skips and take untils and everything else that you can have in your pipeline, then having shorter, more describable pipelines are something that you want to do, and think about how you break down your APIs and your API calls along the way. Now, so concat map certainly is useful if, once again, you're dealing with sequential data and the world is good. But for a lot of things that we're going to be doing, especially in Rx, is that it's kind of indeterminate in terms of how much data that you're going to see. So for example, we could do our mouse moves and mouse drags example, and that would be the mouse down and merge and mouse move. So those merge map, I'm taking in the original mouse down and then combining that with the mouse movements. So those two events are now fused together, as it were, through merge map. And what you can also do is then calculate kind of the deltas between where you started with your initial mouse down, but any subsequent mouse movements as they come along. We'll start to go through that a little bit more later in this series, especially when we're going to talk about the drag and drop scenario. But for the most part, what we're going to do is talk about here is talking about the autosuggest example. And the autosuggest or autocomplete scenario is something that's very, very familiar to a lot of us, in that we want to be able to give the user incremental feedback as they are typing their queries out. So for example, if they're on Wikipedia, if they're on Google or Bing or whatever service, or even GitHub, whatever your service may be. And you want to be able to give the user some hints as to what data is going to be pulled back based upon their typing ahead. And so to do that, we have, for example, we have the Wikipedia's OpenSearch API, and that allows us to query any particular term and come back with a result. So here we can use the Axios library. Once again, you can use pretty much anything that you want to here. I just like doing that because Axios very, very easy to use. Simple get with some parameters, and we get some results pretty quickly. Some people like using the Fetch API, whatever floats your boat in terms of getting data. So we're using our newfangled search Wikipedia async function instead of just returning a new promise and thenning onto it. I've actually deconstructed it into an await and projecting the value of the response of the data that comes back. And if you do a search on Wikipedia, what you get back is actually a promise of array data. So for example, if we went and looked at the code, let's go and switch over to our code view. We can go in here, and we can, instead of just doing this, we'll comment out all of the stuff that we're doing here, and that we'll cover a little bit later. And we can just say search Wikipedia. So let's search Wikipedia for React and then and console.log. Cool. And running that. All right, cool. So what we get back is we get a multi-dimensional array in the fact that we have our first piece here, which is well, actually no, we don't get but we do get an array of arrays originally coming back, and since here we're truncating it to giving back response.data. So what we could do instead is, let's get rid of this here, in terms of telling it what we were getting, and just say return response. And so return response then will give us what it originally gives us, which is our multi-dimensional array, which will give us any number of pieces of data here, such as the React React piece and then its inner pieces. So we searched for a React, it gave us this, and it also gives us may refer to as another piece that we just particularly don't care about at this point, but we obviously could fill it out with richer information as we see fit. So cool, it gives us a lot of information that we can, use later on. So now what we can do is we can simulate that we're getting some sort of user input. And to do that, we can say, all right, let's do that from just in node land, use the event emitter. And so the event emitter, we can keep sending data back here, and it'll be captured as string data, and we'll come through and we'll search Wikipedia each and every time that things come through. So we can say, all right, we're going to search for foo and then bar. So obviously we're going to do a lot of searches here. Now, when we run this, what happens exactly? All right, so we get our results back, but what you may not notice at first here is that our results are out of order. And that could certainly be problematic, especially if you're trying to update the user incrementally over time, is the fact that, well, if you went by the last time that I actually gave you data, you thought that you typed in bar, but I'm giving you the answer for foo. Oops. That's certainly not a good scenario where things can go wrong. Because like I said, we're talking concurrency here, and concurrency allows us to complete each of these in any order that they come in, just as long as you give me the results back. So cool, it does that. So we can come through and say, sure enough, we saw results for foo and bar and react and reactive and so on and so forth. But what we saw as well, which was kind of problematic, was this idea of our results being out of order. So what the heck? Let's go back and dive into some code and actually find out why that might be. So let's go into to the source, because sometimes the source is the best way of finding out exactly what's going on here. Let's take a look at our operators here. So the operators that we have, we've used so far is concat and concat-map, and then we had a new one that we're going to be talking about, which is called switch map. Now, what exactly does that do? So what it's going to do, especially if you read the documentation, is projects the source value to an observable which is merged from the output observable, admitting only the last and most recent from the projected observable. So in the case of our previous code, when we were seeing foo coming back after bar, that won't happen here. And why not is because what we're going to do is go through that inner observable and cancel all of the previous ones that happened. So we're going to remove that particular subscription, and I highly recommend that you go and take a look at the code, which gives you an understanding of once it's been fulfilled, okay, great, but if it hasn't, cancel and only give me the latest and greatest. So it's going to keep going through here and canceling the previous ones if they haven't already fulfilled their particular piece of data. Now, switch all, on the other hand, is more like merge all and concat all in terms of trying to smush it down into the latest and only the greatest. We can also take a look at the reference documentation, because like I said, the reference documentation is really good here. So if we go to RxJS .dev, and then we can go to the API reference here under reference. And there we can take a look at our switch map and our switch all. So here, not a lot of data on here, but for switch map there certainly is because it's a lot more used than just switch by itself. So with that, let me go back here, sorry, to switch map. Now, like I said, is that we're only going to want to take the last one of these. So let's go back to our code and see how we can fix this so that we're making all of these queries, but I keep changing my mind as to what the data really should be. So instead of using switch map, or rather merge map, I can use switch map here in our pipeline, and I can then call search Wikipedia. And what's going to happen then? What do you think? Well, what's going to happen is that all of the ones that are going to keep coming back are going to be canceled because they had not resolved yet, because they're all in flight. And since they're all in flight, I can go back and say, I don't care about this result, that result, that result, and that result. So we only get one answer back for this. Now, there are other ways, of course, we can tame the user input, and we'll be talking about that in the next segment for taming user input. But so far, like I said, is that we really care about making sure that the piece of data that we're getting is the right piece of data so that it doesn't confuse the user, and that's what switch map does. We also have the variants going back to our browser here. We have our variants of, like I said, of switch all. So when we talked about concat all and merge all, now we can talk about switch map 2, which once again, no matter what happens, we give it this particular value, no matter what the outcome of the inner sequence is. We can just say that this is the value that we should be using going forward. So just to give you another set of things that you can research on your own time, there's exhaust and exhaust map that are more edge case, but are certainly useful operators that you might want to look into. But I'll let those be exercises for the readers going forward in terms of how far you want to dive into Rx. So exhaust map, fairly interesting operators in and of themselves. But when we're going to talk about taming our user input, we're going to start looking at things like debounce and debounce time, and those particular two operators, and then we'll compare and contrast those with what throttle and throttle time mean, just how we can control the user input. So not only that, but we can also start to think about distinct data as it comes along. So either truly distinct data through the distinct operator, or whether it's something as simple as distinct until it's changed, meaning if foo keeps on coming through, then when it changes to bar, I want to be notified, but only distinct until changed, and then suddenly, oh, I've got a new value. Let's go ahead and give you that new value there. So that's kind of teasing us as to where we're going with this particular set of posts. But like I said, is that this is as much of my series as it is your series. So I hope that you're getting a lot out of this in terms of what is the art of the possible with Rx. So with that, I'll go ahead and wrap this episode up here. So thank you very much for watching. I hope you subscribe, Bluer Than Blue Falcon here on Twitch, on Twitter at Matt Podwysocki, MattPodwysocki, and find me on YouTube as well. And once again, this is much your series as it is mine, so please do give me suggestions on what to cover next. I've got plenty of ideas of my own, but I really want to hear what you all think as well. So leave some comments here, leave some comments on the repo, on GitHub there as well for this particular repository, and I will see you next time. Bye-bye.